So some good practices. I don't just show bad stuff. So these are these Cymatco cabinets that I really like. They're marine grade plywood coated with epoxy, chemically resistant. They meet fire code, and they're really durable. So here's an example of excellent storage. We have slide lock. So first we've got doors on cupboards. So in case of an earthquake, shelves, bottles fly all over the place in a shallow earthquake. They just launch. So those little earthquake lips seem really nice, really don't do much in a major earthquake. Or if you knock a bottle over, it'll stop it from rolling off the shelf, but that's about it. And quite often I find people either have completely ridiculously insignificant earthquake lips that are like a 1/4 inch high, which really do nothing, or they're so high that you have to tip every single bottle up and sideways in order to get it out, which can actually create other health hazards. These are nice because they've got doors and they've got just simple sliding bolts to lock them closed. So in case of an earthquake, bottles are flying around all over the place inside the box. And everything inside the box is compatible with everything else inside the box. Nothing's coming in contact with each other. They're labeled with the contents so we know what's inside. And on the counter, we've got their dilute solutions. They're working with this quarter. These are all 1 molar or less. And they're all in secondary containment. And you can see they're using all kinds of different things for containment. You don't have to buy some industrial supply company secondary containment. Any plastic tube for eyedroppers, a cafeteria tray works fine. So yeah, these Cymatco cabinets are great. They cost a little bit more, but they really last. The corrosive one, there's no metal at all in that thing. It's got a wooden dowel for the hinge. There's secondary containment trays for catching any little spills down in the bottom. They're just really well designed. They come in all sizes. If you're going to try stacking them like this, you'll want to check with the fire department before you do it because they may not allow things to be stacked. And even if you do, I always recommend that you get an L bracket set up for any of your flammable or acid storage and mount it up into a stud on the wall so that it can't tip over and fall. This is something that's also on the handouts that you'll eventually get. So if you look at the Flynn Scientific Catalog or J.T. Baker or any of these other ones, they'll have these storage patterns for chemicals. And typically you need 24 locations to store things. And I never visit stockrooms, especially in high schools and middle schools, that have enough shelves to store things in 24 locations. Those shelves get filled up really, really fast. So I looked at what they had and I went, you know, like the oxidizers, they have the I3s, which are the nitrates and nitrites. The I6s are the borates and chromates and manganates and permanganates, and the I8s are the chlorates and chlorites. And they're all the same hazard class. If we disposed of them, we would put them all in the same drum. So you can put them all on the same shelf. So now we've combined 3 of them into 1. And by combining things that are compatible with each other, I got it from 24 locations down to 12, which you've got a better chance of being able to do that. So this is another thing that's in the handouts, this little sheet. It's also, if you go, I have a website that has a lot of these materials. It's called the Rehab the Lab website. So if you just go to Google or any place else and you search for Rehab the Lab, we're the first hit. If you search for Rehab Lab, you'll find out how to cure cocaine addiction and alcohol abuse and stuff like that. So the is important in there. But that includes, this is downloadable in a couple of different formats from that location. And that's also where the science inspection checklist is available online too. Signage is another area where I find issues with storage. This is the labels that were on those cupboards. Really nice. They've got the codes that go along with it, and they've actually got examples of the chemicals that would go in there. There's the only flammable storage refrigerator I had seen prior to this. Really nice labeling, flammable material storage refrigerator, chemicals only, no food. And then they actually don't have any biohazards, but it's a biology experiment thing. There's no blood flowing around, but no food or beverages of any kind. And you need, this is a health department thing. So you can't put your lunch in the same refrigerator that you've got anything that's being used for experimentation. As far as how much flammable storage requires a flammable cabinet, that's a local ordinance. So each fire department, each fire district will have its own regulations about how much flammable liquid can be stored outside of flammable cabinets. For some, it's 5 gallons. If you've got 5 gallons, you've got to have a cabinet for storing it. And once you have that, then all your flammables need to be in there. For others, it's 10. Literally, it's like crossing the street. You enter a new district, and the regs are completely different. You guys have the best labels in schools, flat out. So label requirements remain the same under the globally harmonized system, where the labels, you have to have a name that matches the safety data sheet. So you can look at the bottle and go, oh, it's propionic acid. I want to know more about this chemical. I have the right to know. I'm going to go look at the safety data sheet, and I would look under the P's, and I would find propionic acid. The one on the left, which is 0.1 m NaOH, what letter, if you don't know, and you flash a little bit of that from the carboy onto your shoe, and you don't know anything about chemical names, what letter of the alphabet in your safety data sheet book would you look for the bottle on the left under? N, right? Are you going to find sodium hydroxide in the N's? No, that's an OSHA, WSHA, Labor and Industries violation. It's an improper label. The other thing you need to have is you need to have warning so people can look at it and know what, right off the bat, what hazards they should watch out for. So the propionic acid, this stuff really burns, is actually pretty good because it's a combustible liquid and it's corrosive, so that kind of captures both, but it doesn't really meet it very well. The one on the left, the carboy, is beautiful. Corrosive substance, very dangerous to eyes. That's a great warning. You know exactly, it's like, I better wear goggles when I'm working with this. It's corrosive, I better wear gloves. And it doesn't matter that it's 0.1 molar, because if it starts drying out, the water's going to evaporate and it's not going to be 0.1 molar anymore.
Do you have a label that's better than like the paper sticko? Is there a label that is specialized for chemical bottle and maybe has some plasticized?
I know people get a laminator and they use that, like a little name take laminator. Those work really well. We find real problems with this for the arts community, the people who do print work, where they're working with inks and they're using solvents that dissolve inks. For them, trying to make labels that don't dissolve, that hold those solvents that are designed to dissolve inks, is a horrible problem for them, because it's can't find anything we can write with that this stuff doesn't dissolve. So they've gone with the laminated labels as a way to deal with that. Yeah, shipping tape, the heavier duty stuff can also help. Covering it, that'll slow it down. Here's a couple of my favorite labels. The Mind Freak, but the good part is it's only 2 molar, so it's not concentrated Mind Freak, which would be mind-blowing. And then Methyl something. I've always liked that one, especially since they misspelled methyl. It's, I mean, this really totally does not meet the OSHA requirements. A couple more. Biuret. You may know what biuret is, but it's not based on people who know what it is. It's based on people who don't know what it is, being able to know what it is. And the bad students was great. That was down in Richland. I went, bad students? He goes, oh yeah. It's first day of class. Just bring out the jar. I don't say anything. Any questions? And it's got bones in it, Mount St. Helens ash. That was great. He says it works. Class control for at least a couple of weeks with that thing. So one of the classic questions I get asked is, I've got these little barrel pipettes, and I barely have enough room to write the chemical formula on it, let alone the full name and the hazards. So how do I do that? So the one on the left does not meet OSHA standard. The one on the right does, even though the pipettes themselves just have 0.2 m CuSO4, because that's all they could fit on it. As long as the chemical is under your control, there's no requirement for any label to be on it at all. So you don't need to label your little half-liter bottle there, because it's under your control. You know whatever it is that's in there is what is in there. As soon as you go home at night, if it's a chemical that's hazardous in any way, you need to label the bottle in such a way that it lets other people know what it is. Name and warning. By replacing those pipettes back in this cup, which has the symbols that are on it and has the code that explains what it is, you meet that requirement. And the fact that it's 0.2 molar, there are no hazards associated with 0.2 molar copper sulfate. It's not toxic. It's not corrosive. It's not reactive. So you don't need to have a hazard warning because there's no hazard associated with it. Now, if it was, I don't know, 15 molar copper sulfate, then you'd probably want to write toxic underneath it. So that's a way to get around that. But you can't just leave the pipettes out in a clear thing without them going back. And things like the unknown A and unknown B and unknown C, having a piece of paper that has the cheat sheet codes really doesn't work. Because I've gone to your stock rooms and I know how many pieces of paper you have. And nobody can find the cheat sheet anymore for these old ones that your predecessor made. And now you're making new ones. It's like, well, the ABCs, I don't know what those are. So I'm making 1, 2, 3s now. And somewhere around here, there's a piece of paper that says what that stuff is. So you need to put it back into a box or something. And in the box, it describes what's what. So inventory control is a big part of chemical safety. So you need to have a complete inventory of all of the chemical containers that you have in your school, especially that are hazardous. One of the problems I find is the first thing is, how many of you have an up-to-date complete inventory of your chemicals in your science stockroom? Good. That's a higher percentage than most. So one of the problems we find is the initial inventory is just a pain. It's really incredibly time-consuming and hard. And one of the problems I find is that people either get stuck doing it alone, which is cruel and unusual punishment, or they start trying to calculate how much is in here. So this was 591 milliliters originally. So how many mils do you think that is now? That's maybe 200, 250, 175. You know, we each independently would probably come up with a different number. And if there's two of you doing it, you start going, well, I don't know, is it 150 or is it 200? You know, and 3 minutes later you agree that it's 200. And you've done one out of your 900 containers. Or you do it and then it's like, all right, so I know we've used a bunch of stuff, so now we need to do inventory again. And you're going to have to look at every single bottle and go, okay, so last year we said this was 200. You think it's 190 now? And you will not do your second inventory because it's like, oh, I remember this now. No, I think I'm going to apply for another job. So when I was down in the Tri-Cities, I saw this box, and it had the word restock on it. And I said, so what's that? And they said, oh, it's the restock box. I said, well, how does that work? They said, well, when we use up a container of something, we put the empty container in the restock box. I go, okay. And then when we need to buy stuff, we go to the restock box and we buy stuff. I go, all right. I said, so what's so special about that? They said, well, we only track containers as if they're full. So when you buy your 591 mils of reagent-grade Coca-Cola, you enter it into your inventory as 591 mils, and you put it on your shelf. 7 years later, when it's this much in the bottom, it's still 591 mils of Coca-Cola on your inventory, because all you're measuring is the container size. And that's where the beauty of the restock box works. Because once you do your initial inventory, the only things that are going to change on your inventory is dependent on what you do with the restock box. Because anything that's still on the shelf is still in the same container. Nothing has changed on your inventory. So the stuff that goes in here, it's like, all right, so are we going to buy any more methyl ethyl death? It's like, oh yeah, I totally need the methyl ethyl death. It's like, well, we had a 500 mil container last time. Is 500 mils okay this time? Yeah, that should be fine. All right. You don't change anything in your inventory because even the empty bottle is still a 500 mil container of methyl ethyl death. So as far as your inventory is concerned, you still have that container on site. You don't need to change it. When you buy the 500 mils, when the new bottle shows up, you put it on the shelf, and then you dispose of the empty container in the trash because empty containers are exempt from the hazardous waste regulations, and your inventory never changed. So for down in the, I think it was in Richland school district, they said, yeah, it took us about 16 hours to do the initial inventory of all the chemicals in the high school. And our updates that we do every year take about 7 minutes. So the restock box is the way to make updating your inventory really, really easy and really non-threatening. And you actually can keep up your inventory without dreading the beginning of each new year or the start of, August coming, and it's like, all right, here comes, the fall classes, and I've got to get this inventory updated again. And they've turned the power off to the stock room, so it's going to be really stuffy and really hot and dusty, and I hate going in there, and you don't do it. And doing it electronically is really the way to do it, because then you don't lose the pieces of paper. It's like, oh, we've got A through K, and then the L's and M's are all missing. That piece of paper must have fallen on the floor and gotten swept up by the custodian. So as I mentioned, about a 5-year supply of chemicals, or the smallest available size you can buy, whichever is most. So if this is the smallest size container I can buy, and this is a 15-year supply of something I need, it's the smallest size you can buy. Buy the smallest size you can buy, even though it's more than 5 years. If you're going through 3 gallons a year, then you don't buy the smallest. It's like, oh, I could get this in a 100 ml container and spend 10 times as much for my hydrochloric acid as I would if I bought it by the case. Because you're going to go through 2 cases every 5 years. Buy 2 cases. That's just a real straightforward rule of thumb. 5 years is a pretty good. Some things last a lot longer, but a lot of things don't. Some of the dry compounds, copper sulfate. I've seen bottles of copper sulfate, they're 50 years old, they're still working just fine. Copper is very toxic to most organisms besides mammals, so it's not going to bacteria is not going to do anything to it. It's just going to get killed by it. As I mentioned, if no zip code, it's before really 1963. As far as safety data sheets, one of the questions is, well, where do I get these things if I don't have them? The brand new globally harmonized safety data sheets aren't required to be sent out to you until 2016. And then you'll start seeing these new, much more thorough safety data sheets. If you want to get them now, the Sigma Aldrich website, they are a massive chemical supplier. They have hundreds of thousands of different chemical compounds. And you can just go to their site and do a search. So I just type in carbon disulfide, and it just drops down all the different ones they've got. I click on the top one there, and I get different grades. I just click the MSDS button, and boom. You can print it out. The nice thing about working with pure chemical compounds is you do not need to get safety data sheets from your distributor or manufacturer that you bought it from, because copper sulfate's copper sulfate. It doesn't matter if it's from Science Lab or Flynn Scientific or Carolina Biological Supply. It's a pure chemical compound. New improved Tide has been new and improved about 42 times. You need to contact your supplier to make sure you're getting the one that you actually purchased for something that's a product like that, that's a commercial product. And what's nice is we have new globally harmonized stuff. So what you've got is you've got all these classifications, and you've got pictograms, and you've got hazard statements. This is what the new labels are going to be looking like too. Way more information. They will have all of these hazard statements on the label as well as in the safety data sheet. It's a great thing. We're finally becoming globalized and joining the United Nations. So as far as safety equipment, you can now get galoshes for high heels, in case you guys are thinking about it.
Real quick about the MSDS, is the requirement to have them printed out on paper and in a binder?
Great question. So you can have an electronic copy, but you need to have an alternative power supply. So in case the power goes out, which is, major earthquake, bottles spilling all over the place, and the power went out, and I can't boot my computer, which has my fancy Dan safety data sheet list. So if you want to buy a giant generator just to maintain your safety data sheets, so yeah, a paper copy. If this is your stock room, the place you want it is just outside that door. You don't want it in the stock room. Oh, the bottle just spilled, and now I'm going to have to stand in the puddle in order to find the safety data sheet to take it out to the firefighters to let them know what I just got exposed to. Yeah, the idea would be is if something's happened to where you need to evacuate the room, usually it's involving more than one chemical compound, And what you want in that book is only the chemicals that are in this area. And same for all of your stockrooms. So just have safety data sheets for that particular area, and then a master down at the front desk in the building or something like that. And that way you can just grab that book and run down, and you're not grabbing the book of all books worth of safety data sheets and trying to thumb your way through. It's very specific to what's in that one location. Great question. So when you're choosing gloves, and there'll be this little video will also be at the FTP site. I like disposable nitrile. They're not very expensive. They're not permanently resistant to the compounds you're working with, but they do a pretty good job of resisting for at least half an hour to most things, which is what I'm looking for, because I'm not planning on bathing my hands in stuff anytime soon. I want to be able to look down and go, whoops, I got contaminated, pinch the glove, turn it inside out, throw it in the trash, put a new one on. I'm not looking for something that's going to last a long time. The two things you want to look for, and there's a glove chart that will also be as part of the handout, is you want to look for breakthrough time. So that's how long it takes to do something like this, where it dissolves the glove and creates a hole in it that the chemicals can go through. And permeation rate, which would be, you could still inflate your glove, but when you pull your hand out of the glove, you've got chemicals all over your hand. So it just permeates right through that material as if it's not even there, even though it's still intact, as far as you can tell. And as I said, if you know you're going to be working with acetone a lot, then something that you work with regularly would be a good place to start. Check for acids that you work with. Check for flammable liquids that you work with. One of my favorite searches in Google Images is doggles. Hundreds of images of dogs wearing goggles. It's just great. So when do you wear goggles and when do you wear safety glasses? If you're working with hazardous liquids, you should be wearing goggles. Another great Google Images search, Burning Man. Can't go wrong with that one either. But the thing to remember is that just because you're wearing something that's protecting your eyes doesn't mean you don't also need to protect the rest of your body. Yeah, this was a pretty good dust storm, I think. If you want to watch a fairly terrifying video that Labor and Industries created, it documents splashes that two workers in the food industry got. And they were wearing some protective materials, but they weren't really adequate for what they were working with. The National Science Teachers Association has a great guideline for eye protection at their website. I really strongly encourage you to go to it. And as I mentioned, that's a hot link in the PowerPoint. And then hazardous waste disposal, kind of finish up here. So for something to be hazardous waste, first it has to be a waste, and then you determine whether it's hazardous. As long as it's useful, it's not a waste. So anything you don't want anymore that can't be used by somebody else, it's like, well, I don't need this product anymore. Like, well, first check around to see if some of the other instructors can use it. If they can, it's still an article of commerce. Hazardous waste regulations don't pertain. But if you can't use it, nobody else can at your facility, you don't know what it is, like waste everything. It's orphaned, so if you go back to your school and there's a 55-gallon drum sitting in the parking lot and you don't know what it is, you should not assume that it's air or water. You should assume it's probably something nasty. Chemicals are pretty much guilty until proven innocent. And then anything that's spilled where when you clean it, you can't use it again. These would all be examples of waste. So then once it's like, all right, that's a waste. The next question is it hazardous? So hazardous materials can have either characteristics, which are things like flammable, corrosive, actually it's ignitable, corrosive acid, corrosive base, reactive, reacts with water, reacts with air, spontaneously ignites, oxidizers, things that are fire accelerants, or toxic materials that are toxic by inhalation, ingestion, skin absorption, or aquatic toxicity to salmon and trout. Or it could be on a list. So they have a list in the Washington State Dangerous Waste Regulations, and that list has a bunch of chemicals on it. There are way more chemicals out there than we can list, so the characteristics are typically what we use. Washington State has the most stringent hazardous waste regulations in the country, by far. There are thousands and thousands of chemicals that designate only in Washington State as toxic hazardous waste. like salt. Sodium chloride is a toxic, hazardous waste in Washington State. I know, it's crazy, but it's true. Nobody, no, as long as it's over 10% in concentration. So no small generator of salt waste has ever been arrested or dinged for improper salt disposal. Large ones maybe, if you've got like 7 tons, you'd probably have to dispose of that as hazardous waste. But if you're the Washington Department of Transportation and you've got tons of salt, or the city of Seattle, for example, and you crush it up and you spread it around on the streets where it can wash off into the storm drain right into the sound, that's perfectly fine because you're using it as a product and it's not a waste when you're applying it, and that's normal use of it. So, like I said, nobody gets busted for illegal disposal of salt, but it gives you an idea of how crazy our toxicity characteristic is. And the reason it is it's a logarithmic progression. So we have stuff like cyanide, clearly, astonishingly poisonous. And that's way down at the bottom of the curve. And then we double, we do 10 times that. It's from 0.1 to 1. And now we're getting into things that are still pretty toxic. And then we 10 times that. And now we're getting into things that are pretty toxic, like copper sulfate. And then we went 10 times. We went one more time. And we went from, and this is in lethal doses to rats and stuff. And we went on, the curve went like this. And way up at this point on the curve, at just below the threshold where it's non-hazardous, is where salt lives. And I've always said, if you just stopped here, you would have captured a whole lot of stuff that the rest of the states don't capture that actually is pretty toxic. But you had to go one more, and next thing you know, Tylenol and aspirin designated as hazardous waste. If things we eat regularly are toxic, well, maybe, but that seems dumb. But I digress. So the rule of thumb in Washington State is that everything you have that you're going to, that's a chemical, is probably toxic in our state, or corrosive. So you should never assume that stuff, I use this stuff all the time, it's probably non-toxic. You're wrong. The odds are 95 to 5 that it's going to be toxic hazardous waste. So your assumption should be any waste that you have that is a chemical in nature will need to be disposed of as hazardous waste. But there are still things you can do about that. There are things that are not hazardous waste. Like I said, things that are still useful. Empty containers. So as long as you've emptied the container out by normal means and it has less than 3% of its initial contents in it, it can be thrown in the trash. There are a lot of things that are hazardous, like ninja cats, knives, and revolvers that are not chemical in nature and therefore are not part of the regs. So this is the rule of thumb on the empty containers. If it's an empty container of a flammable liquid that's very volatile, like an acetone bottle, once you've emptied it, I would prefer that you then fill it up with water and purge all those flammable vapors and then pour the water down the drain because it was exempt and it's empty. And that way you don't have a bottle full of flammable vapors that's breakable in your trash bin. And it won't get broken and you don't have to worry about somebody smoking cigarettes behind the dumpster and setting your dumpster on fire. And the same thing with acids and concentrated acids and concentrated bases. Fill those, once they're emptied, fill them up with water and pour the water down the drain. You can definitely use those for the waste, but you may find that you're using up more than, so if you've got, but if they're empty containers, absolutely, they're the best possible storage containers for waste.
What about little dropper bottles,
They're still containers, you would use the same calculation, 3%. A little tougher to calculate out in weird shaped little things. So your basic regulatory requirements for hazardous waste is you have to know what it is, which means the container must be labeled. We cannot dispose of unknowns. Hazardous waste gets disposed of in very specific ways depending on the hazard characteristics. If it's flammable or combustible, it's probably going to go to either a cement kiln or an ocean-going vessel as a fuel, bunker fuel, because they burn a lot of BTUs in order to make cement. If it's too toxic for that, it'll go to a scrubber-equipped chemical incinerator, probably in Texas. Acids and bases go to somewhere in the Midwest where they have a giant tanks where they neutralize things out. If it's mercury liquid, it's going to go to Pennsylvania and go to a giant $750 million retort furnace, which is basically a big stainless steel distillation apparatus that boils off the mercury and recondenses it, and then it gets stored in bunkers in hidden locations somewhere around the country, forever apparently. So everything has its own spot to go. If it's just toxic and it's a dry solid, it's going to be put in a 55-gallon drum that's lined with absorbent material, and it's going to go to Eastern Washington to Chem Security Systems, triple-lined, piezometer-equipped, low rainfall landfill where things are three-dimensionally mapped. So eventually they'll go back in and start mining them because it'll be cheaper to dig out the hazardous waste drums than it will be to extract the raw stuff at some point. You have to document everything you do with your hazardous waste in writing somehow. Because when I show up and say, so how do you dispose of your hazardous chemicals? Properly is not an adequate response. It's like, nice, so what's that mean? Well, here's our disposal paperwork we got from the company that picked it up. Or we dropped it off at the household hazardous waste site, and this is the receipt they gave us. And here's, we keep copies of all the stuff that we generate, and here's the copies of the hazardous waste records that we've got. Some non-hazardous stuff can go in the dumpster or down the sewer drain. Sugar, starch, corrosive from the biology lab. That stuff is propylene glycol based. That can go down the drain to the sewer. Water, vinegar, plaster of Paris, Epsom salts, pH, all of those things are non-hazardous and can be disposed of. As far as your biology tissues that are pickled in formaldehyde, formalin solution of 10% formaldehyde, and then that gets decanted off, and they've got the holding solution that's non-hazardous. The specimens themselves still have residual formaldehyde, but the King County Health Department has determined that it's acceptable for those to be double bagged and disposed of as solid waste. I always recommend black plastic bags just because they tend to be pretty disgusting looking, and that way people won't be either freaked out or tempted to open them and play with them.
And we called our local, waste department and asked about it, and they were, they said the same thing.
Yeah.
Up in Skagit County, but our custodians don't like it. They don't like
Oh, I don't blame them.
seeing that
Yeah, it's
dumpster.
grody. Some counties do not allow it. It actually technically does designate still as a toxic hazardous waste in Washington State. So it's a local, solid waste regs are local regulations. Sewer regulations are local regulations. Stormwater regulations are local regulations. And fire regulations are local regulations. So depending on which town you're in or county you're in, they're going to change. And that's always a challenge for people who move to Washington State from other states who are really up on, it's like, oh yeah, I'm from Oregon, I know what can go down the drain, what can't. It's like, no, you don't. Because all kinds of stuff that is perfectly fine to throw in the dumpster in Oregon is totally illegal to throw in Washington State. As I mentioned, try to keep your hazardous chemicals out of drains. I will always ask if you put anything down the drain. So you can treat your hazardous waste. And the two we find people generate the most from science labs are inorganic acids and base solutions, and especially aqueous metal solutions, especially in high schools. These are really common. So my recommendation for the aqueous metal solutions is that you put them in a Ziploc baggie lined beaker or bucket or something, and you pour the dilute solution in there and let the water evaporate out, and then you add more of the solution in and let more water evaporate out. A 0.1 molar copper sulfate solution is 99.4% water. So when you fill a Ziploc bag full of this blue water and it dries out over the summer, let's say, you're going to have a few tiny little crystals down in the bottom of it. So just keep refilling the bag. Once the bag gets filled up with sludge, enough where you can still zip it closed, then that's when you need to replace the bag. This is one of the things I see people do is they have like a beaker for their barium waste and a beaker for their copper waste and chromium, and you can mix all of those metals together. They're all going to be disposed of together. You do not need to separate out all of the metals. You do need to keep track of everything you're pouring in, the amount and what the major constituents are, because you're still generating that liquid as a hazardous waste, All you're doing is you're reducing the volume to save you money on disposal. But the waste you're generating is at the moment you can't use it, that's when it's designated a hazardous waste. So if you had 100 mils of that solution, you generated 100 mils. Even though it ends up being a mil of sludge, that's how much you're paying to dispose of as the mil of sludge, but you generated the 100 mils. And the reason you have to track this is you need to be under 220 pounds per calendar month of hazardous waste generation to be exempt from a whole bunch of regulatory requirements. And that's for your entire building.
With that, is it also, so you have to count the stuff you neutralize, the stuff you keep. Does it count for the, like, say, broken glass?
No. So, and even on the stuff you neutralize, so for acids and bases, the corrosive hazardous waste is pH 2 or less and 12.5 and above. So if you generate a waste that's pH 2.5, it's still pretty darn corrosive. It's not a corrosive hazardous waste. It doesn't have that characteristic.
So you don't have to record that?
You would not have to record, that's not part of the regs. There's no requirement to record that. So 2 and less and 12.5 and above are corrosive hazardous wastes. Anything in between is not a corrosive hazard. It may still be toxic, but it's not a corrosive hazardous waste. And you don't count the product that you add to neutralize. So if you use 0.1 or pH 1 sodium hydroxide to neutralize your hydrochloric acid, even though the sodium hydroxide would designate it's not a waste, you're using it as a product to treat your waste, you only count the acid waste. You don't count products.
And is that like average or like, you know, because like I came in and there was a lot of waste that wasn't disposed of because no one was doing it?
So it's all at the point where you designate it as being a waste. It's like, okay, I just showed up, and as far as I'm concerned, this is a waste. Ding, it's a waste.
But if it's over,
You are allowed to store 2,200 pounds of hazardous waste on your site before you have to dispose of it, which is a lot. Please don't.
no.
Just curious, how much do they charge to dispose of something like that?
I'll get to that. So when you get your Ziploc bag full, what you do then is you have a 5-gallon bucket like that, and you take your Ziploc bag over and you put it in a 5-gallon bucket, you close the 5-gallon bucket, and you go start a new Ziploc bag. And when that one gets full, you put it in the bucket. And when the bucket gets full of Ziploc bags, then you dispose of the bucket. For a typical high school, it could take 40 years for you to fill that bucket. Because remember, it's 99% water. It's going to take a long time to fill that up with sludge. You're going to have to...
Aren't we supposed to dispose of it within 90 days?
Oh, so this gets into generator status.
Okay.
And I don't have time to get into it. So if you are a conditionally exempt small quantity generator, you generate under 220 pounds of hazardous waste per month, which most high schools and middle schools are, then you can store it on site until you have 2,200 pounds before you just, it could be 100 years. If you generate between 220 pounds and 2,200 pounds in any calendar month, then you have 180 days to store it from the day you put your first drop of hazardous waste into a container. Your clock ticks 180 days later. Sooner than that, you have to dispose of it. If you're a large quantity generator and you generate over 2,200 pounds in a calendar month, or over 2.2 pounds of some very scary stuff like cyanides and stuff, and you've got 90 days. So it really varies. And this is where regulations change between states. Okay. So you keep a log when you're treating. Because again, you're generating it. I'm going to come up, it's like, oh, what do you do with your aqueous metal solutions? Oh, we evaporate it. Prove it. Well, I got a bunch of sludge over there. How do I know you didn't generate the sludge? I have a log sheet that shows what I put in. So keep a log sheet on your neutralization activities and keep a log sheet on your treatment by generator activities like evaporation. That's a requirement in the regulations. Optional. You can incorporate treatment into lessons. So if you've got something that's a pH 1 waste and you're like, well, we're going to do an acid-base neutralization lab, take the waste over and neutralize it up to pH 2.5, and then say, all right, I'm done using it as a product. Now it's a waste. Oh, now I declare the waste. Now we test the pH because it just became a waste. Hey, it's 2.5. It's not hazardous waste. Doesn't count towards your generator status. So you can be a little tricky. It needs to pass the laugh test. It's like, oh, we're doing a lab where we spray hazardous chemicals all over the lawn. Hey, now it's a waste, but it's part of the lawn. So you have to dispose of hazardous chemicals as hazardous waste. There are options. If you're in King County, you can generate under 220 pounds per calendar month. You can deliver up to 4 times per year for free your hazardous waste to our household hazardous waste sites and just drop it on off. If you generate over 220 pounds, if you're a fully regulated generator, you're not allowed to participate in it. We do have a form that you fill out online to do it. Different counties allow small quantity generators. Sometimes they charge. I think Snohomish charges a fee for it. We used to charge a fee. We don't anymore. It's a real nice incentive to get down below 220 pounds. If you're going to deliver it yourself to a drop-off site, please separate your unlike wastes so that storage in small spaces gives you some good ideas about how to separate things. Acids in one, bases in another, and then drive them over separately. If you are driving them, do not put them in the passenger compartment of the car, because if you get in a fender bender like these people did, you're going to launch all of your chemicals all over you. And if it's a 5-gallon bucket of latex paint, it's kind of funny. If it's acids and flammable liquids in glass bottles, it's really going to be terrifying. So much better to have it in a pickup truck under a canopy where there's a barrier between you. If that doesn't work, at least in the trunk. So it's got to make its way through the back seat before it can get to it. And we'll zing through the quiz very, very quickly. So what you do is for each of the photos, just shout out what the issue is that you see. Poison, very good. I like everybody goes bleach and ammonia. It's like, duh, that's not the issue. Yeah, they're together. This one's a little subtle. Yeah, so this was non-potable water. It's like, so whose coffee cups are those? Obviously somebody you don't like much. Yep, very good. My favorite crystals ever. So there's a couple things wrong here. So one, what the hell are those crystals? So those are ammonium nitrate crystals. So there's a leaking bottle of ammonium hydroxide somewhere. What else is wrong with this? Yeah, the cap's really messed up. What else is wrong with this? The label is wrong. No warning, and what letter of the alphabet would you look for this safety data sheet under? H. You're going to find nitric acid under the H's? I don't think so. Can't reach the handle on the safety shower?
Don't use those gloves.
Exactly. So reusable gloves can only be reused up to a certain point. No flammable liquids in a refrigerator. And an animal, yeah. So, yeah, you don't balance bottles on top of bottles of hazardous chemicals. So, yeah, too much stuff for the storage area. That's my favorite. That's my favorite label. Exactly. What's the other 95%? Because it's not water. And then this one actually is pretty subtle. So this is the container. When I opened it up, they wrote the label. They put the label on themselves, and they wrote it on the styrofoam, and it's been stored for like 5 years upside down. That cannot be distilled water. So red caps, nitric acid. Nitric acid is an oxidizer, eats its cap. And then this was the 13 pounds of lead nitrate I was telling you about.
Don't eat around your
Cyanides. Yes, that's a really great rule of thumb. So that's a copying machine in the stockroom. Yeah, it's the only copying machine for the whole floor, so they have to keep the stockroom unlocked so the kids can come in to pick up the printouts. And the flammable liquids are stored right next to it. Yeah. So I'm going to finish up with just a little story. Meet Farmer Dave. Dave owns 17 cows, and he has 3 sons. He's not looking very healthy. So he calls in the lawyer and he says, I want to write out my will, and I want to give half of my cows to the oldest son, a third of my cows to the middle son, and a ninth of my cows to the youngest son. The lawyer writes it down, Dave signs it, lawyer notarizes it. A day later, Dave dies. Boys show up, excited to get their cows, and they start trying to do the division, and it doesn't work. 17 divided by 2 gives you 8.5. 17 doesn't go in, 3 doesn't go into 17. 9 doesn't go into 17. Tempers rise, fight breaks out. They roll out the front door, yelling and screaming, and their neighbor, Pam, hears this thing that says, boys, what's the problem here? And they explain the issue. She goes, I think I can fix this. So Pam walks back to her farm, and she comes back with her prize cow. Says, you can have my best cow. And then they do the math. And 18 divided by 2 is 9, and 18 divided by 3 is 6, and 18 divided by 9 is 2, which adds up to 17. And Pam takes her cow home, and everybody's happy. The moral of the story is that we make assumptions about stuff all the time, that things can't be solved, that issues are the way they are because they should be that way. And we get into problems with safety making those kinds of assumptions. There's no such thing as accidents in chemical safety. There's shortcuts. So the chemicals you work with the most, things like methanol and hydrochloric acid, are the #1 and #2 source of chemical accidents in schools. Methanol by far in #1. And it's because we work with it all the time. So we just kind of get used to it and stop worrying about it quite so much, and then something goes wrong. So don't be chemically complacent out there.